Good afternoon. Today we are working on CO10. I can apply the order of operations on expressions with rational numbers. Now, very often, I will say there's lots of different ways to do math, as long as we're getting the right answer. When we do order of operations, I'm going to be a little bit of a stickler and say do it this way. Set up your problems this way. Because I know what's coming. I know what math is going to look like next year and the year after. And I know the problems that people run into. So this is one of the objectives where I say, nope, I don't want you to do mental math. I don't want you to organize it in a different way because I know what's coming. So I really need for us to pay attention. Because I have had students who thought they knew better than me, who said, I don't have to do it Miss Gambino's way, it's too much work, it's busy work, I can do mental math with this, it's not a problem. And then we get to the spring, and all of a sudden they look at me like deer in headlights, saying, what, I don't know what to do, why am I getting them all wrong? I don't understand this objective, it's not working. It's because they're not in the habit of setting up their problems the way that they need to set it up. It matters, okay? So there's not many times I say you have to do it this way. Order of operations, you need to get in the habit of setting it up a specific way because it will get much more complicated, okay? As you go through math, it gets more complicated. We're in the habit of setting it up and solving it in an organized way. When it gets more complicated, you just take it one step at a time and it's not a problem. If you're not used to taking it that one step at a time, it becomes a problem. So, imagine a world without rules for solving equations. Consider the following. 3 plus 4 times 7 equals 49. Or 3 plus 4 times 7 equals 31. Without the order of operations, one could make a case that either answer would be correct. But because of the order of operations, we know there is only one correct answer. And we can figure out which one it is. So we have our order of operations. PERMDAS. And anybody know what the P stands for? AJ?
Parentheses.
Parentheses. That is the very first thing you do when we do order of operations. Do the parentheses. What is the E? Colton?
Exponents.
Exponents. Anybody know what the R is? Henry?
Radicals.
Radicals. Exponents and radicals are at the same level. They are opposites of each other. We're going to be learning about those. What is the M, Laurel? So what is the D, Ellen?
Division.
They are on the same level because they are opposites of each other. 7 times 3 is 21. 21 divided by 3 is 7, right? They work together. What is the A, Holland?
Addition.
And what is the S, Finley?
Subtraction.
They are on the same level because they are opposites of each other. 2 plus 3 is 5. 5 minus 3 is 2. So we have 4 different levels. Parentheses. Exponents, radicals, multiply, divide, add, subtract. If all operations in the equation are on the same level, it doesn't matter which one we come to first when we're reading from left to right. If it's adding or subtracting, whichever one we hit first, that's what we do. If we're looking at multiplying and dividing, whichever one you hit first, that's the one that you do. We have to be careful with that, because so often I have friends that skip the adding that's at the end of the equation and then come back to do subtracting. And you will get the wrong answer. If it's on the same level, you read left to right, either one. So really, it's fun to say PERMDUS because it makes kind of a goofy word that we can say to remember order of operations. But what we really should do is have our parentheses and then exponents and radicals together, multiply, divide together, add, subtract together. Because it doesn't matter which one you hit first. We just can't make a word out of that. So, parentheses is always first. Inside the parentheses, you follow the order of operations. So if you have adding and multiplying, you follow the order of operations inside the parentheses too. So we're going to see what those steps look like for our order of operations. First, let's look up top. Which one do you think is right? Knowing our order of operations. Is the answer 49 or is it 31? What do you think, Gavin?
31.
Well, let's see if Gavin is right. What would be the first thing I would do in this equation? Ellie?
Put 4 times 7 in parentheses.
Instead of, oops, nope, you said 31. I'm going to take that out. So instead of putting it in parentheses, what I do is you're going to make your little caret, because that's what you're going to do first. Why are we doing that first, Ellie?
Because in the order of operations, that just it's what comes first.
Yeah, there's no parentheses, there's no exponents or radicals, there is a multiply divide. That multiply, so we have to do that level first. So 4 times 7 is 28. I'm going to bring down the rest of my equation. So you bring it straight down. We're going to kind of narrow down our expression until we get to our answer. Now we only have one operation left. 3 plus 21 is 31. So we can see that that was truly the correct answer. What problem did they make when they got 49? Clara?
Then 3 plus 4 and then times it by 7.
They added first and then multiplied. But adding and subtracting is the last level. We can't do it before the multiply dividing level. This is how we're going to be setting up our order of operations. So let's look at this. It says evaluate each expression and show all your steps. It doesn't mean that I'm going to do my math over here and then I'll do, okay, 12 plus 12. And I don't want to see a hot mess. No hot messes on our papers, okay? When we get to the complicated, harder math, at the end of this year, and going into algebra, and then, oh my goodness, once you get to calculus in high school, you can't be doing hot mess, okay? You have to be organized. Organize, organize, organize. So, 12 plus 4 times 3, what's my first step I'm going to do? Laurel?
Put parentheses correct.
Not doing parentheses. I'm just going to match up what my operation I'm working on first. Okay, so 4 times 3 is 12, so I put it right under it. It's like I'm pointing down to what that answer is going to be, and I bring down the rest of my expression, 12 plus. Now I'm going to do this operation, 12 plus 12 is 24. That's my final answer. Let's look at our next one. 3 divided by 3 minus 2. What do I do first? Madeline?
2 divided by 2.
3 divided by 3 is 1. Bring down the rest of the expression, minus 2. The operations and the numbers that you haven't used yet. What is 1 minus 2? Emily, negative 1. So we will be working with those negative numbers. Let's look at this one down here. 6 minus parentheses 4 plus 2 parentheses squared divided by 3. What is the first thing I want to do? Elliot,
4 plus 2.
4 plus 2. So that is 6. I'm going to bring down everything else in my expression. I'm going to keep rewriting my expression until I narrow it down to the answer. So I'm going to bring down 6 minus, I've got a square, divided by, and a 3. What do I do next? 6 minus 6 squared divided by 3. Colton.
Do 6 squared.
6 squared, because that's my exponent. All right, that's the exponent level. No more parentheses, so now I'm at exponents and radicals. What is 6 squared? Henry,
36.
what math did you do to get it?
I did 6 times 6.
Yeah, because our base number is the 6, and we see the 2 as the exponent. That means we multiply that 6 by itself. 6 times 6. So I see 6 times 6, that 6 is there 2 times, because our exponent is a 2. If our exponent was a 3, 6 to the 3rd power, I would multiply that 6 3 times. It's not 6 times 2. It's not 6 times 3, if it's 6 cubed. It's that base number times itself. Our exponent tells us how many times we're going to multiply it out. So be very careful. 6 squared is 6 times 6, which is 36. And I bring down the rest of my operations. So now I have 6 minus 36 divided by 3. What comes next? Ellie.
36 divided by 3.
Yeah, because I have to divide before I can subtract. So 36 divided by 3 is what? Laurel. Hunter. 12. I'm going to bring down the rest of my expression, 6 minus. What is 6 minus 12? Elliot. Negative 6. See how I'm just rewriting it underneath itself and narrowing it down, doing one step at a time. Yeah, it's a lot of writing. Is it hard writing? No, it's not, right? I'm not asking anything complicated, but I am asking you to stay organized so we don't miss anything. We don't miss a number, we don't miss an operation. We know exactly what we've done and what we're going to do next. Stay organized. Could we look at this and do half of it mental math? Yeah. I'm sure you could. But that's not what we're practicing here. We're practicing getting into the good habits. It will help you in the future. Trust me. I truly know what people struggle with in the future objectives. With pre-algebra in the spring, Mr. Schultz has sent me what they do in algebra and just how complicated things get. And if you're not in the habit of doing it organized, you will struggle. So start getting in the habit now. All right. It's possible for each expression below to equal 30, but not as they are written. Add parentheses where necessary to change the order of the solving process so that each equals 30. So if we have 5 plus 5 times 3, where do you think I want to put the parentheses so it'll equal 30? Ellen?
5 plus 5.
Because if we were at 5 plus 5 times 3, the first thing I would do would be 5 times 3 is 15. Plus 5 plus 15 would be 20, not 30. So I have to put parentheses in there. Now the first thing I do is what's inside those parentheses. 5 plus 5 is 10 times 3. Oh, look, my answer is 30. You might put in one set of parentheses. You might put in two sets of parentheses. But every one of these expressions we can make equal 30. So you have to play around with that number sense. What numbers do we want to add or subtract before we multiply or divide? Where do I need to put those parentheses? Then at the bottom it says write two expressions, each with 4 operations from PERMDAS. Make one expression equal 25 and the other equal 100. So let's work on that 25 together. And then you're going to do something to equal 100. It's like the 5-card challenge. We have to use 4 operations. So you're going to use 5 numbers, right? Because 4 operations. And we have to have our final answer be either 25 or 100. So it's like the full-on 5-card challenge, using all 5 cards, but you get to pick what the numbers are. Can anyone think of something that we could do that would equal 25? Elliot?
We could do 5 plus 10.
Okay.
Times 2. Minus 9. And then parentheses 1 with 5 plus 1.
So, what is this going to equal? To equal 25, the 25 one? Okay, so first thing I would do would be 5 plus 10 is 15. 15 times 2 is 30. Minus 5 is 25. Let's look at our operations. We used 4 numbers, but because we use those parentheses, that counts as an operation. So parentheses is one operation, plus is a second, times is a third, subtraction is a fourth. So we used 4 operations, and we made sure to follow the order of operations to equal 25. You can come up with your own, or you can use that one, but you have to come up with one for 100. There is not one right or wrong way. Lots of different examples out there. Lots and lots and lots and lots. So you could use this one, or you can come up with your own, but be thinking how you can manipulate those numbers to have your final answer be 25, have it be 100. Now, it does say up here you can check your answer with a calculator. We will not be using a calculator on the test for this one because I want to know that you know the order of operations, because I know our calculator knows it. We have to be very careful when we use our calculator that we are putting it in exactly like we see it. I showed you guys the parentheses buttons, right? Have I shown you that yet? Or was it the other class? Okay. So let's look at that calculator. Our first one with parentheses. We have 20 divided by parentheses. So use that parentheses. 3 plus 2 parentheses. It's super important that you put those parentheses in so your calculator knows the order of operations that it's supposed to follow. Because if I put the parentheses in, I get a 4. Let's look at what happens if I don't. If I say 20 divided by 3 plus 2. Oh my, I get a big long decimal. Very wrong, right? Because the first thing the calculator does is 20 divided by 3. And then it adds 2. So you have to make sure that you are putting it in exactly how it's written. Okay? Any questions on this? Do you guys know how to use the square button on the calculator? Okay, so you've used the square button?
Yeah.
Henry, you've used it. Does everybody else? Do you want me to show you? Okay. So because we do have some exponents in here. So make sure that if you're checking it with your calculator, you work it out first yourself, check it with your calculator, and if you get a different answer on your calculator and you're not sure where you went wrong, come check with me, because it could be that you put it in your calculator wrong. If you are watching this from home, I hope you are well, and I hope to see you soon. Have a wonderful day. Don't forget to like and subscribe.